Hello everyone, today I am going to introduce to you how to troubleshoot SI23 fault. First, before troubleshooting any fault, you need to check the last fault status. Start by checking C01 parameters group. In this group, you will find all the necessary information about the fault, such as fault type, voltage and current, and other relevant data. First, identify possible causes. Excessive load. The load is too heavy. You can reduce the load or you can replace high capacity inverter. Short circuit. Look for short circuit on the inverter output side or to ground. Motor damage. Ensure motor is not damaged. Cable length. Verify that the inverter output cable length is within the maximum allowable value. First step to troubleshoot. Check your software version. For software version C00.28, 6908 and 6907, increase the deceleration time using F00.15. For software version 6920, increase the deceleration time using F01.23. Run fault test. Check if the inverter reports a fault when running without a load. Also, test it with the motor cables removed to see if the fault still occurs. Analyze the overcurrent fault. If the inverter occasionally reports an overcurrent fault, reset it F00.19 to set 1. First, identify the fault. This fault occurs when the load is too heavy and the acceleration time is too short. Adjust acceleration time. For software version C0028, 6908 and 6907, increase the acceleration time using parameter F00.14. For software version 6920, increase the acceleration time using parameter F01.22. Test motor insulation. Disconnect the motor wires and measure the insulation of the motor to the ground. Run inverter test. Check if the fault occurs when the inverter runs with the load or with the motor cable removed. Analyze overcurrent faults. If the inverter occasionally reports an overcurrent fault, reset it and observe. Check if the fault current C01.04 is low or if fault occurs. The EOV4 fault occurs when the bus voltage exceeds the overvoltage limit. 820 volt for 3-phase input, 400 volt for single-phase input. Measure input voltage. Use a multimeter to check the input voltage. If it is too high, consider replacing the PV type to match the input voltage. Initialization. If the fault voltage is normal but the fault persists, try initializing the parameters F00.19 to 1. Control board, power board. If initialization does not solve the issue, replace the control board. If replacing the control board does not resolve the fault, the issue may be with the power board. The E.OV3 fault occurs when the bus voltage exceeds the maximum allowable value during the constant speed operation. Measure bus voltage. Verify if there are any fluctuation causing the voltage exceed the limit. Initialization. If the input voltage is normal but the fault persists, start by initializing the parameters F00 0.19 to 1. Control board, power board. If initialization does not resolve the issue, replace the control board. If the fault continues after replacing the control board, the problem may be with the power board. For software version 6907 and 6908, increase deceleration time F00 0.15. For software version 6920, increase deceleration time F01 1.23. Power voltage fluctuation. Check the input power if voltage fluctuation exceeds the limit. If fault still persists, reduce load on the system, or you can select a bigger capacity drive or connect a braking unit. For software version 6907 and 6908, increase acceleration time F00 0.14. For software version 6920, increase F01 1.22. Power voltage fluctuation. Check the input power if voltage fluctuation exceeds the limit. Restart motor unit. It runs completely, then set for software version 6907 and 6908, set F01 1.00, 1 or 2. For software version 6920, set F07 1.00, set 1 or 2. If fault still persists, reduce load on the system, or you can select a bigger capacity drive or connect a braking unit. Adjust both acceleration and deceleration times to reduce overload. Ensure inverter and motor power match. Monitor C00 0.02 to check if the inverter's output current exceeds the motor's rated current. Motor parameter settings. Set motor parameters based on the motor nameplate. For software version 6907 and 6908, set F0501 to F0506 parameters. Overload protection adjustment. For software version 6907 and 6908, increase the F10.16 motor overload protection curve coefficient. For software version 6920, increase the F10.59 motor overload protection curve coefficient. Factory reset. For software version 6907 and 6908, restore factory setting with F00 0.19 to set 1, then power off and power on again. For software version 6920, restore factory setting F0003 to set 22. the load is too heavy, inverter capacity is small, reduce the load or replace a high capacity inverter. Compare output currents. Use a current clamp meter to measure the three-phase output current. Ensure all phases currents are balanced. Check the C00.02 parameters and compare with the clamp meter. If incorrect, change the current detection circuit or replace a new power supply board or control board. Do motor auto tuning. After set the motor parameters, do a complete auto tuning for proper operation. For software version 6907 and 6908, set F0521 or 2. For software version 6920, set F02.07 1 or 2. Increase acceleration and deceleration time to prevent sudden overloads. Inspect the wiring for any faults or disconnection that could be the reason for phase loss. Turn off phase loss protection. For software version 6907 and 6908, close phase loss protection F10.15 to set 0020. For software version 6920, close phase loss protection F10.20 to 0020. Inspect three-phase output voltage and current. Measure the three-phase output voltage and current to identify if there is any unbalanced current or voltage. Insufficient PV power. Check if there is a problem with the PV panel configuration or inspect the bus voltage. Measure the input voltage and check the value of C00.11. Frequency not increasing. If the frequency cannot increase during the operation, adjust the parameter to enable a smoother frequency rise. For software version 6908 and 6907, set F10.03 to 000, F0800 to 10, F14.06 to 1, F14.07 to 20, F14.08 to 30 or 50. These settings are commonly used for single-phase motors. Switching operating modes. Check if changing F14.00 to 0000 allows the frequency to rise. Inverter output cable too long. If all parameters are correct, the issue might be due to the motor output cable is too long. Consider adding a output filter or reactor to resolve this issue. By following this step, you should be able to troubleshoot. If issues persist, consult the manual or seek for further assistance. Thanks for watching.